Hi, my name is Jack O'Connell, and I'm an infrastructure consultant for Applied Information Sciences. In this session, we will share an example of Platform as a Service web role workload in Windows Azure. We believe that by demonstrating a sample workload, it affords us the opportunity to showcase different Azure constructs. The workload being discussed today makes use of the following Azure constructs: a private data center extended into multiple Azure Regional Data Centers, an East Coast and a West Coast DC, with IPSEC tunnels. The on-premises AD DNS infrastructure extended into Azure IaaS. SQL Server 2012 servers configured with the Synchronous High Availability Group. The High Availability Group has a local on-premises primary and a remote secondary located in Azure IaaS. And a Platform as a Service web role, which is load balanced across data centers using Azure Traffic Manager. So here we are in the traditional data center. Scaling and failover was done with capital upfront expenses, and you paid for the entire solution, not just what you needed. As we all know, times have changed. Literally, what was not possible yesterday is possible today. We see features and functionality being rolled into the platform at an amazing rate. Whether it is on-demand scaling, spinning VMs up and down in minutes based on need, extending your data center, either using point-to-point data center connectivity or IPSEC tunnels, all while continuing to leverage your enterprise tools for both on-prem and Azure resources. Best of all, focus on business needs and workloads instead of the underlying infrastructure and planning required. One of the first topics that we will discuss is the Azure Virtual Network. Here you create an IP address space with subnets for isolation. You can assign DNS addresses so that you can provide the machines assigned to your VPN DNS servers. This is also the place where you define your on-prem IP address space and configure your IPSEC tunnel and gateway. As we discussed, you can extend your on-prem data center by setting up an IPSEC tunnel. This allows you to not only extend your data center, but also your IP address and namespaces. You can also extend Active Directory and all your other underlying infrastructure that provides a foundation for the workloads that your business needs. So let's go ahead and set the stage. In the past, the diagram above depicts a scenario that was desired by many companies, whether they were small or large. Data centers in multiple regions, points of presence in multiple regions, data within the data center replicated into other data centers located in other regions. For companies with locations in multiple regions, where they had a footprint, this was more feasible but still expensive. With companies without a footprint in multiple regions, this was too expensive to build and support. In either of those situations, this model represented where you paid up front for what you built and not for what you need. So let's begin building from the simple data center into the hybrid data center world where complex workloads can be explored. In this setup, you can see we've got an on-prem data center at the bottom of the diagram, and we've got an Azure virtual network running in the West Coast region and an Azure virtual network running in the East Coast region. So you can see that I've logged into my subscription in the Windows Azure portal. You can see here the default directory associated with my subscription. I've selected a specific subscription that I have rights to. And I've navigated down to the Networks tab. On the top here you can see virtual networks, local networks, and DNS servers. Here is my East Coast data center. You can see that here it shows you that it's in the East Coast, and then here's my West Coast data center, which here it shows you that it's in the West Coast. If we go ahead and bounce into the East Coast and go to configure, you can see I've created a couple DNS addresses. And here's my total address space along with several subnets defined here. If I go into the West Coast and go to configure, you can see the same thing. I've got some DNS addresses I've defined, and I've created, here's my IP address space with a couple subnets defined. If we go back to the dashboard again, you can see down here the subnets with the machines in those subnets. And the same thing goes for the West Coast. So as we discussed and I showed you, we have built out our East Coast and West Coast virtual networks, supplying IP address range, subnets, creating some DNS addresses, and added machines into those virtual networks and subnets. The next thing we can do is go ahead and set up our IPSEC tunnels and our gateways so that we can extend the data center into those newly created virtual networks. We're back in the Azure portal, and as you can see, here's my local networks. I've created one called OpDC, and you can see that I've gone ahead and configured a gateway. I've provided my on-prem environment with the required key in order to create the IPSEC tunnel. The tunnel's been established and we have connectivity. Yeah, now that we've extended the network into Azure, we can start extending the underlying infrastructure pieces, as I mentioned, such as Active Directory, so that we can make use of those already established services that we've been using in the enterprise. So as I mentioned, I've extended the network through IPSEC tunnels so that the on-prem environment can connect to both an East Coast virtual network and a West Coast virtual network. As you can see here, these are the machines that are in the East Coast network, and the naming scheme here is AZ represents Azure. And you can see I've actually provided a West Coast designation in this name to show that this is the West Coast, and that's in the virtual network in the West Coast. So if I already keyed into a server already, this is the AZAD box that's located in the East Coast, and from there I already keyed in again to the on-prem AD server. From there, just to demonstrate the connectivity here, I've gone ahead and mapped the drive straight back to the East Coast, and then done the same thing so I can connect right back to the West Coast. So once that connectivity is established, then you can begin really building on top of that connectivity and doing things like extending the other underlying infrastructure, such as Active Directory. I believe everybody knew where I was going with that once I showed the AZAD name. So here is my management console for Active Directory sites and services. As you can see, I've created the subnets and some sites. Here's my East Coast site, here's my West Coast site, and here's my on-prem site. You can see that here's my on-prem Active Directory box that we're connected into right now. And in the East Coast, you can see that I've actually created an Active Directory server in the East Coast and went ahead and made it a domain controller. Same thing is true on the West Coast. I've created a machine in the West Coast I showed you, and I made it a domain controller as well. All these servers are also running DNS, so I am using my own DNS in Azure as well. So my Active Directory infrastructure has been extended into Azure in both data centers so that we can begin leveraging that as well. So as we discussed, once we extend into Active Directory and establish connectivity, extend Active Directory, we can begin domain joining machines and leveraging the other enterprise tools that we use in the environment. Not all the tools require that we have a VPN established. For example, here I have a SQL 2014 box, and in SQL 2014 you can now configure maintenance plans where the destination for the backups can be Azure Blob storage, and that does not require a VPN connection. Also, if you see here, I have the Windows Azure Backup Agent on the machine as well, and with that you can back up directly into Azure without the use of a VPN. And if I come down to recovery services, you'll see that I've set up two different backup vaults. One vault's being used for Data Protection Manager. You can see that I've registered the machine in Azure, so it can back up directly into Azure. And then the other vault is the backup agent that's running on the SQL box. So if we come back in here, I mentioned Data Protection Manager. Here's my Data Protection Manager machine, and as you can see, I have backed up some data into Azure. If I come to Protection, I can come into here, modify the group. See, I've got a couple machines in here. You can see that I'm backing up the disk, and then I want online protection. And with all these, with the backup agent, you can throttle and schedule the backups so that you can be mindful of the bandwidth utilization in the environment. So there are options that are available to you to leverage resources outside of the VPN connection, where you can take advantage of those things using, you can take advantage of tools available in Azure to back up and manage some things in your enterprise environment without extending your data center. So, having said that, just brought up my SCOM server, And if you can see here, I've got a couple different management packs installed. One of them is the Azure Management Pack, and with the Azure Management Pack, again, you don't have to extend your network to be able to utilize the Azure Management Pack. You'll see that I'm capturing some metrics for services in Azure here. Just bouncing through real quick so you can get an idea. And another thing I would like to mention on that topic as well is that on another machine I'm running System Center App Controller, and here you can see that I'm looking at a private cloud environment and my public cloud environment, and that I can manage both from here. You can see the services, and if you notice, some of them are Azure machines. And you can see all the Azure machines that I have turned off and on. You can see here I've got a couple map drives, I've got my Azure resources, and I've got my private cloud resources as well. To finish out the conversation about leveraging your enterprise tools once you've extended into Azure, here is SCOM with some of the traditional management pack tools. This is all about Active Directory for the most part. There's some memory, disk capacity. So basically, if you look down here, you can see that there's a mix of Azure machines and on-prem machines that are being monitored. I've also got a System Center Configuration Management server. And in here, just quickly wanted to show you that I've got an malware report that I've got, just to show you a little bit that, yes, with System Center Configuration Manager, I'm actually monitoring servers for anti-malware, and also using the compliance tool to look at compliance in the environment for both on-prem machines and in Azure. Back to the slides. Now that we've extended, got Active Directory running, got all our enterprise tools in place, let's talk workloads again. So as we discussed, we have an on-prem SQL 2012 server, and the desire is to add an additional SQL 2012 server in Azure, and then set up a high availability group so that we can have a primary replica on-prem and a secondary in Azure with synchronous replication, so that the primary is writable, secondary will be a read-only copy, and when a failover occurs, the secondary will take over and become the primary. Let's go ahead and connect in and take a look at the SQL environment that we currently have on-prem. I've connected into my Azure Active Directory box, taken a hop into the on-prem Active Directory box, and now connected to the on-prem SQL Server. Here's my cluster. You can see the two nodes in the cluster, and here's my availability group, and currently the owner is the on-prem SQL Server. go into SQL, you'll see that here's my database that I'm using for the application. It's synchronized. Here's my availability groups. You can see that I've got my availability replicas. The on-prem is the primary. The Azure one is the secondary. It means currently the on-prem SQL Server has the writable copy of the database, and the Azure has the read-only copy. To finish out the conversation, let's go ahead and jump in to my on-prem Active Directory box and connect to the Azure SQL Server that I've created. If I go into Collector Manager, you can see that it's got the same information and has the same view of the world. If I jump into SQL, you'll see that it has its perspective of the world. The database is synchronized. It's acting as a secondary, and here it lists itself as a secondary. So it's got the read-only version of the database. Back to the slides. So now that we've got our SQL environment stood up, where we've got our primary and secondary servers, we can now build on top of that by adding the Windows Azure Platform as a Service web roles, one in each data center, and point them to our SQL servers. For demonstration purposes, we've went ahead and in the East Coast data center, we're pointing our web role to the secondary that's in Azure, and in the West Coast data center, you'll notice that we're pointing the web role back on-prem to the primary SQL server. So therefore, the West Coast has the writable copy of the database, and the East Coast has the read-only copy of the database. So let's go back into Windows Azure and into the subscription and go to Cloud Services, and you'll see that I've created two Platform as a Service web roles, one on the East Coast and one on the West Coast. And if we go back down to our networks again, you'll see that in the East Coast, got our web role in a subnet in the virtual network. And if we go on West Coast, you'll see the same thing. And what this means is, since we do have Active Directory that's been extended, we can domain join these web roles. And in addition to that, since even though they are web roles and we don't have to patch them or maintain them the same way we would a standard IaaS server, we are able to RDP into them. So here is my East Coast web role. As you can see, here's my simple MVC application. Simple home page. It's got some user data, and since it's in the East Coast, I've given it a description that says it's in the East Coast and it uses data from a backend SQL server that's located in Azure. To So if we come into the web config file, you can see that the data source is 10.0.1.5. We come back into the Azure portal and come into the East Coast Data Center, and you'll see that 10.0.1.5 is the SQL box that's running in Azure. And in the West Coast, same application. It's got some data, and again, it's in the West Coast, and it uses SQL Server, which is on premises. If we go and look at the web config file, its IP address for its data source is 10.1.1.8. We go back to Azure, to our RDP session through our AD box and on-prem. Here's our on-prem SQL box, and you can see I've done an IP config showing that the IP address here is 10.1.1.8. So as we just discussed, we've got the web roles in the environment up and running. I showed you a little bit about the configuration of the Windows Azure Platform as a Service web roles. Now that we've discussed all that, let's go ahead and talk about Traffic Manager. So in the environment, we basically have two different regions with two different web roles, one in each region. One has a writable copy of the data, one has a read-only copy of the data. So we're going to go ahead and set up Traffic Manager so that it can be set up for failover load balancing. So the primary in our scenario will be the West Coast web role, and the secondary will be the East Coast web role. So let's go ahead and go back to the web roles, and let's go to the West Coast, since the West Coast is the one with the writable copy of the data currently. And here's our application, and in addition to the application, we actually had to create a virtual directory with a page in it so that we could actually have a probe location where anonymous access would be turned on, so that when we set up Traffic Manager, we could probe the boxes and determine the state of the system. So we did that in both the West Coast and in the East Coast. Here's the probe page in the East Coast. So if we go into Traffic Manager, you'll see that we have a load balanced URL with two endpoints. And both of them are online, which means the probe is working. And let's go ahead and take a look at the configuration. So here's our load balanced DNS address. The time to live. Here's where we establish the failover type. Again, we're using failover. We are using failover, not round robin or performance. Performance is based on proximity to the nodes from the client. And as you can see, we're still online. We're using HTTPS. And here's the probe location. Let's go ahead and do a little Traffic Manager testing. Let's grab the load balanced DNS address. We're not using a trusted certificate, so that's why we're being warned. It's prompting me for credentials. Since this is a domain machine, join machine, we are using authentication, basic authentication. As you can see, we got in, and since this should be the West Coast, since that has a writable copy, we set up the Traffic Manager for failover, and the primary node was the West Coast and the secondary the East Coast. We should be in the West Coast. So let's go ahead and look. It says welcome to the West Coast. So there you have it. And since it does have the writable copy of the data, we should be able to come in here and make a change. And let's see that it's saved. And it does. And if we come into the East Coast and go ahead and refresh the information in users, you'll see that that changed to a 2. So we're all set. So let's go ahead and finish our load balance testing. I've gone ahead and gone into our West Coast location and stopped IaaS. So when we come back into Traffic Manager, we see that the status is degraded. We go to our endpoints, and we see that the West Coast status is degraded and the East Coast is online. And again, based on the configuration failover priority list, the West Coast is first, but it's in a degraded state, so the East Coast should be taking the traffic. So let's go ahead and try the application again. And I got in with my cache credentials, and I see that I am now in the East Coast. So the load balancer has sent the traffic to the proper location, and again in the East Coast we still cannot edit the traffic. The data. We've discussed our web role and Traffic Manager and how the traffic is routed to the West and East Coast. Let's go ahead and talk about SQL. We have discussed that the primary is on-prem and the secondaries in the East Coast data center, but in a failure scenario, the secondary will become the primary and the East Coast will have the writable data, whereas the West Coast will then have a read-only copy of the data, since the primary will become the secondary. I'm going to go ahead and log on to our on-prem SQL box, which is right here. You can see I'm in the cluster manager, and still, as we discussed, the on-prem server is the primary, and therefore our West Coast web role has the writable data, and our East Coast web role has the read-only copy of the data. So in SQL, again, it's showing everything same way, it's consistent. Let's go ahead and failover to the Azure SQL Server. And there you have it. We're now up in the Azure Data Center. The database has been failed over. Let's see what SQL thinks of that. Let's do this a refresh. And now, as you can see, it still says it's synchronized. It now says that the on-prem SQL Server is the secondary and the primary is the Azure SQL Server. So if we go ahead and return to our web roles, and we go into the West Coast, who had the writable copy of data, You can see it's still set to 2. Let's go ahead and try to change that in the West Coast. And we shouldn't be able to do this since the West Coast now has the read-only copy. And there you go. It's getting a read-only error. And if we go into the East Coast, we should now be able to edit the data. And there you have it. It took. And if we go back to the West Coast, you can see that it reflects the changes. So the synchronization is still occurring. It is getting the data, but in the West Coast now, it's not able to change it because it has a read-only copy. Our workload transformation into Azure is now complete. As we have discussed, once you build your base topology, the scenarios are limitless. I think this is a compelling scenario that demonstrates some exciting capabilities that are possible once you move out of the traditional data center and into a hybrid data center. I really appreciate your time today, and if you have any questions, I'd be happy to answer them. And please do not hesitate in contacting me.